So today we're going to be talking about solving systems of equations by graphing. A system of equations is a set of two or more equations with the same variables. More specifically today, we're going to be talking about systems of linear equations. So those are going to be straight lines. We've got a few different ways that we can describe our systems of equations. We can describe it as consistent, meaning that they have at least one ordered pair that satisfies both equations. We can call it independent, where the graphs intersect at exactly one point. We can call it dependent, where they are the exact same line, which would mean that they have unlimited solutions. Or we can call it inconsistent, where they have no ordered pairs that satisfy both equations, and that would mean that the graphs are parallel and that they never intersect. So below we have a bit of a diagram just to go through that vocabulary a little bit better. So like we said before, when we've got one exact intersection, we can call it consistent and independent. If they are parallel to each other and never intersect, we're going to call those inconsistent. And if they are the exact same line, we're going to call that consistent and dependent because they have infinite solutions. Moving down to our steps, we're going to make sure that our equations are in slope-intercept form first, and then we're going to graph both of those equations, and then we're going to decide if they have one solution, no solution, or infinite solutions. So we're going to go ahead and get into this first example here. So with our first example, we're going to make sure that they are both in slope-intercept form, which they are because they are both y equals. And then from there, we're going to pick out our slope and our y-intercept for both. So for this first one, our slope is 2 and our y-intercept is -7. And then for our second equation, our slope there is 2/3 and our y-intercept is +1. So we're going to go ahead and graph both of those. I'm going to start with that first one. It intersects at -7. And our slope is 2, so that tells me to go up 2 and over 1. So I'm going to go up 2 and over 1, up 2 over 1. I'm going to do that just until I get enough ordered pairs to connect. And it is really important that you guys make sure that this is as straight a line as possible. So you might want to use a straight edge or a ruler just to make sure that you're getting the correct solutions. So on that next one, we've got a y-intercept of 1 and a slope of 2/3. So we're going to go up 2 and over 3, up 2 and over 3, up 2 and over 3. And I'm going to go ahead and connect those. And we're going to find that point of intersection. So, and then if I had graphed this line a little bit straighter, this is why I said it's important for you guys to graph it as a straight line. So if I kept going with this up 2 over 1, we would eventually see that they do have a line of intersection. My line just wasn't as straight. So there we go. All right, so where they cross, that is our common solution. So it does have one solution. And our solution is the ordered pair for the intersection. So our x value is 6, and our y value would be 5 because it's between 4 and 6. So that's for our first equation, or system of equations. So it's got one solution. In our next one, we're going to, again, make sure that they're in slope-intercept form. So here they are not because our y's are not by themselves. So we're going to go ahead and get our first equation into slope-intercept form. Since our y is being multiplied by 9, we're going to divide by 9 all the way through and rewrite. So I'm going to say y is equal to x divided by 9 is the same thing as 1/9 x, and -27 divided by 9 is -3. So that's going to be our first equation in slope-intercept form. And then we're going to go ahead and do our second equation. We're going to move that x over first and get that on the same side. So we've got -x plus 18 is equal to -9y. And then we're going to divide by -9 all the way through and rewrite. So there we would have y is equal to Negative divided by a negative is a positive, so we get positive 1/9 x, and 18 divided by negative 9 would give me negative 2. So those are our two equations, and we're going to go ahead and graph those. I'm going to start with the first one. So our slope for that first one is 1/9, and our y-intercept is negative 3. So we're going to go down to negative 3 and use our slope to graph. So we're going to go up 1 and over 9. And go ahead and connect those. And then same deal, we're going to go to that next one, crosses at negative 2. We're going to go up 1 over 9. Okay, and that's going to keep going. And those are parallel. I know my lines aren't super straight, but they are parallel. So that means that they have no solution because they never intersect. And remember back to our parallel and perpendicular. We've got the same exact slope here, so it should make sense that they graph to be parallel. Okay, we're going to move on to the last one. We're going to make sure that that is in slope-intercept form as well. So for that first one, we're going to subtract 2x from both sides first and get 3y is equal to negative 2x plus 15. And then we're going to divide by 3 all the way through. So we've got y is equal to negative 2/3 x plus 5. And then we're going to do the same thing with that second equation that is already in slope-intercept form, so we don't have to convert that. So we're going to go ahead and graph those. As you guys can see, they have the same exact slope and the same exact y-intercept for both. So when we graph those, they're going to be the same line. So they both go through 5 as the y-intercept, and they have the slope of negative 2/3. So we're going to go down 2 and to the right 3. They're the exact same line. So when we graph that, it's going to be all real numbers as our solution. So go ahead and make sure you try the problems in the formative and make sure that your notes are ready to check over tomorrow.